Yeah, I don't think I'm muted either, so I'm hoping this works. Okay, so back to what I was saying, right? Okay. Okay, it's fine, it's fine. I'll rub everything out. So let's just say I'm still starting with these two functions, right? And going with a number that works very well with this, for instance, 5. If I put 5 in, this is going to give me what's that? Like 11, right? This is basically acting like a domain of the inside function because that's simulating what you're putting in. And then this is simulating the range of the inside function because that's what's coming out. But the thing is, what's coming out might not be the exact same as what's required to go into G, right? There's like a connection there. But anyways, if we're purely focusing on the numbers for this question, whatever's going to come out is square root 13. So this is fine, actually. So h of 5 is going to give me square root 13. This is the input, this is the output. Now, the other number that we tried earlier, what was it? -3? Was it -3? Okay, so we'll try -3. -3, -5, and that wouldn't work. It's not allowed because this number is not a part of the domain of G. Because the domain of G specifies what you can put into the second equation, right? Yeah, so you need to make sure whatever comes out of fx, that's the range, you're actually allowed to put into the domain of G. Okay, because let's say the domain of G is it would be -2 to infinity for this question, right? You're only allowed to put these numbers in. So what if the range reduced something like -infinity to 5? Then it wouldn't work because there's a whole bunch of numbers that's less than 2 that you can't sub in, right? That's why you have to make sure the inside function's range is a subset of the outside function's domain.
Makes so much more sense.
Yeah, it's just like you draw the flowchart out, right? And then you're like, oh, right. You have to make sure the number that came out of the first one can actually go into the second one. Yeah, you literally can't sub it in if this happens, and you can totally just figure this out by looking at the range of f for whatever domain it's given, and then the domain of G. Yeah.
Why?
Okay. Okay. Okay, sure. I can do that. Yeah. We'll start from the beginning then. So yeah, range. How do we find the range?
Range.
Yep.
Graph looks something like that.
Graph does look something like that. I'll draw it out on screen as well. Yeah, but look. You drew this out with the endpoint being a -1, but the domain's got starting from 0. So you can only keep this part. Like, it's true that this graph here does look like this, but you can only keep the part that's bigger than 0. So it's gonna look something like that. So 0, 1, I think. Yeah. Wait, what am I doing? 1 to infinity. All right. Is the second part okay? Part B? No? All right. Just read the question first, and what do you think it's asking you to do? Find the largest possible value of C such that the range of G is a subset of domain of F. Okay, so what do we actually know? Well, I think we should focus on the second part. The range of G is a subset of domain of F, which implies we can kind of manipulate G in some way, right? Oh yeah, we can. We can change the C value. Okay, so range of G, whatever that may be, we don't know yet. It's a subset of this thing. It's a subset of 0 to infinity. So in other words, this thing has to be contained within that set, right? In other words, whatever y value comes out of the G graph has to be greater or equal to 0. Yeah, makes sense, right? Okay, let's sketch a graph to see what we're dealing with, so we can evaluate what kind of value we're going to keep. Do you know how to sketch this graph?
Parabola.
Yep, parabola. Yep. So 3, 1, like that. Sure. And I'll just chuck a small graph somewhere. Okay. So something like that. Doesn't have to be too precise. That's -3. That's -1. And this is 3, but we don't care about that. Okay, cool. Yeah, again, it's a very rough sketch, but it has all the stuff that we need. Now let's focus on the first part of the question. Find the largest possible value of C such that the range is bigger than 0, basically. Yeah. What? Okay. Good. That's correct. But why not -1? Yeah. Yeah. Okay. Because first of all, the domain is coming from negative infinity, right? So it's basically everything to the left of C. If you pick -3, it works. But if you pick -1, it'll look like that, and it's under, so we can't use that. That being said, I can pick my C value to be like -4, -5, and the interval would look like this. It just wouldn't go to the axis. Is that okay as well? It's still okay because it's still a subset. The question's asking for the largest possible value, so the largest possible is -3, right? Yeah. So I mean, C equals to -3. Okay. So now that we know the domain of G is -infinity to, what was it, -3? That's gonna be what we're subbing into the graph. Sorry, the function here. And the inside function is gx, so we're gonna deal with that first. And then something's gonna come in. Something's gonna go in here, something's gonna come out. And then it's gonna go into fx. And something else is gonna come out. Okay. So we agree that whatever goes into gx is a domain, which is just this thing. Yeah. Okay. And we know it's going to work, right? Because it's not going to produce any numbers that we can't put into the second equation. Right. So if I put -infinity to -3 in as the x values into gx, what's going to come out? Like, in other words, the range. Mm-hmm. Yeah, good. And we're looking at this part, right? -infinity is 3. Sorry, -infinity to -3 corresponds to this part of the graph, which the y value would correspond 0 to infinity. Okay. We're very lucky here because that's something that's easy to work with. Now, this thing, we're going to put that into F. Yeah. Okay, just a correction. I wouldn't call that the domain because it's not always guaranteed to be the same as the domain. It just happens to be in this case. Yeah. So it's just some numbers, right, that you happen to want to put in there. Like this one could totally just be, I don't know, like 2 to infinity or something, in which case your final answer will be affected. It's totally possible. But we're very lucky in the sense that it's same as what the question was having earlier. So if I put 0 to infinity into f, we already know it's going to be 1 to infinity that comes out, right? Yeah. Yeah. And this whole thing is like the flowchart of how this thing overall functions. So if you want to simplify the slow graph by a lot, you can just say, right, this thing into this whole mess here is going to give me 1 to infinity. But if you have something like that, where there's an input and output, that would just be the domain of like the f of g, and then this would just be the range of function f of g. Yeah, but again, if you want to actually find what it is, you kind of have to do it step by step. Yeah. Oh, sorry, what? That's why you have to make sure the range of the inside function is contained within the domain of the outside. That's the thing I was talking about earlier. Right.
And then, so in this question, per se, like it was negative infinity, so like, or like it came out as not zero to infinity, and it was outside of not containing within zero.
Oh, it wouldn't exist. It wouldn't work.
That's a restriction.
Yeah. Well, restricting it, or rather testing if it exists, is always the first thing you do, right? You always do, oh, is the range of the inside a subset of the domain of the outside? You always do that. That's basically what we did here, right? Because they asked for this thing, and they asked, oh, like what do we have to do to the C value that it works? This is, yeah, it's a very indirect way. Well, it's not even very indirect. It's kind of just asking you to see if it exists or not. And if it does exist, this would work in the sense that whatever comes out here wouldn't exceed what fx allows. It could be smaller, but it wouldn't be bigger. If it doesn't exist, then this is exceeding what fx can take. That's all it is. Okay. Right. Next one might be a bit complicated, but it's an extension of what we just did. It's basically the same thing from memory, I think. Let's okay, just one thing. Since the question here is already telling you to state the range, I'm going to assume it's going to work. I'm going to assume it's defined, like it exists. But let's just do it for good measure. Okay, so the range of h is what? Huh? Okay, 3 to infinity. Yeah, 3 to infinity. No, I thought you said like I thought you said 3 to 10, and I'm just like, where did 10 come from? Domain of f. That's still the same, right? It's still. I thought that. Yeah, that's fine, right? That's inside the other thing. So now we know um, this thing's never going to exceed that. Actually, I'll let you work on this for a bit. Yeah. It's the same thing as what we did earlier, except that they give you a new equation to work with. Okay, so we're looking for the range of this thing, right? But I would have to break it down into the inside functions and the outside functions. So what am I allowed to sub into h, right? And that's going to give me some sort of values. And then those whatever values I'm going to put into fx, and something else is going to come out. Okay, so what? First of all, what are we allowed to put into hfx? Yeah, which is what? Yeah, all real numbers, as it specified in the question. Okay, so we've actually done half of this question already. No, if you put, I don't know how you got 9, but if you put 3 in there, that's just square root of 4. That's 2. Mhm.
Yeah,
Yeah, it's f of x.
Two.
To infinity. Yeah. Okay. So for this question, you know how I was talking about how this thing here, you can only treat it as just some numbers. It's not always the domain, as seen here. We know this is contained within the domain, the true domain, like 0 to infinity, right? But it's just a different set of numbers, which would cause whatever comes out to also be a different set of numbers. But it still work, right?
Yes.
Yeah, we just traced it out through the flowchart. And that would tell us this is the domain of f of h. This is the range of f of h. Simply because that's what you're putting in initially, and that's what's come out what's come out finally. Yeah. So I can also write it like this: R you put into f of h. Instead of writing it like this, I'll write it like this. What comes out is 2 to infinity. Oh, I wouldn't do that because whenever you're looking at a graph, you're estimating, right? That's not like good. It could work, but you don't want to be estimating, especially if it's questions like these. Like for instance, if this one it had like a possibility of whether the endpoint's included or not, like whether two's inclusive, not inclusive, you can't tell on the calculator, right? Yeah, because sometimes it could be like an empty circle, right? But calculator doesn't show that. It's just two. It's just a line that ends there. So yeah, as long as this method makes sense. It does, yeah. Okay. Is that the one that I gave you?
Yes.
Okay, hold on. Who's this is? So which part are we up to? Oh, also, there was, you know how there were two sections? Yeah, you didn't put this one.
Oh, I didn't.
You left it here. Yeah. So where did we get up to? Mapping.
Yeah, but.
Oh, right. Yeah. Okay. Because the booklet kind of skips some things. Because they go straight to recognition. Like mapping and recognition. Recognition is looking at the function and seeing like wherever the stuff is. Okay, so I hope all of these make sense now. Like why a minus makes the graph go towards the right. It should be in your notes somewhere. Transformation. It was mainly like this thing, right? If I assume there's a dilation by factor of n from the y-axis, a from the x-axis, if these were negative, there would be reflections. H is just moving to the right if it's positive, and K is just moving up if it's positive, right? So just using the same unknown variables, we transform this equation over here, and then where it takes us is this very familiar formula, where the A at the front is the dilation from the x-axis, this is the y-axis. You can see how we're talking about how H translates to the right if it's positive. Same thing here, but the negative sign here, right? And then K is just moving up. They're all just a result of us having to rearrange stuff here and there. Like it's just because over here we had to rearrange some things, and that introduced some negative signs in there. It's just like a purely like a formula thing. Yeah, is that okay?
Yeah.
Right. This set of notes. So I'll really quickly glance over all of this because it's just telling you how to read the transformations. But that's that. Yeah, the plus c at the back is just moving it. Yeah. So that's the left and right transformations. This is up down, right? Dilation by a factor of a from the x-axis. In what I've written, I flipped this. Like I had 1 over n here, and then it's dilation from by a factor of n from the y-axis. But it's the same thing.
Oh yeah.
It's just, formula. I had it like this because that's where I started off with mapping with the n just, at the front, and that's where I got what I got. But the basically telling the same thing. Reflections, yeah. Okay, but anyways, I've kind of just skipped over all of this because that's basically what we did last week. Or was it Monday? Oh yeah. Okay. So what do you call it? They've summarized it here basically, and I think this might be what your school is trying to get you to do. Basically, they try to get you to follow every single step one by one to get the answer. It's not a bad way to do this, especially if it's just like, okay, let's say you saw an equation, right? And then you're like, all right, there's clearly 4 different things that's been done to it. You can see the transformations, you can see the dilations.
Yeah, like that.
Like what? Let me see.
Here, well,
Oh, yeah.
just okay, translating this and then you add it to the x and the y.
Okay. So you're talking about the questions where they give you the before and the after, and you have to look for the transformations. That's
They give you the before and they give you the
transformations. Okay.
and they make you and they make you do x bracket y if there's like
Oh yeah. I mean, I can show you how to do it like that here as well. So I'm gonna say this is x, y to start with. Page 20, page 20. Okay. So I'm gonna fill out these later. This is kind of useless. Uh, we're starting off with x and y. You always start off with x and y because that's the original points. And following the exact order, the question's doing it. I know they translated first, but if that's what they did, then you have to follow that. So 6 units to the left would be what? X minus 6.
oh
Yeah, well, it's still left, right? Y. Oh, and for an equation, it'll be x plus 6 because we've explained earlier, due to us having rearranged certain things, there would be like a sign flip here. But originally, you can see how it's a plus, right? Again, that's just a matter of remembering the formulas. Okay. It could get confusing sometimes, but the good thing about doing it by the coordinate is whatever you see is whatever you get. If they tell you move to the 6, like 6 to the left, you just minus, right? If they tell you to go up, you add. Yeah. Okay. What's the next thing? Reflected in the y-axis. Y-axis is it's kind of flipped like this, right? So it's the x value that's changing, and I have to put a negative sign around the entire thing because I'm flipping everything that's there. And dilated by a factor of 2 from the x-axis. Yeah, good, 2y, because it moves the coordinate away from the x, changing the y value. To y. So that's what they're asking you to do. And it basically gives you a set of transformation equations. So x dash is equal to negative x plus 6. I've just expanded it out. And then y dash is equal to 2y. Yeah. Okay. So, and if your goal is to transform this, which is, I hope it's the before. Yeah, it's before. You would make x and y the subject. X is equal to negative x dash plus 6. Y is equal to y dash divided by 2. Yeah, is that?
Negative plus two.
Oh, I mean, just rearrange it, right? Like if I put this here, put this here.
I don't know.
Okay, first of all, x dash equals to negative. Okay, all good? That's fine. So once I make the substitution here, I'm gonna have y dash over 2 is equal to this thing, negative x dash plus 6. And then y dash is equal to 2 times square root this thing. Seeing as how all the xy terms have the little symbol on the top, we know it's after. Right?
So
They have the dash at the top. That's how you know it's after. Because they're not there in the original equation. Okay, so we use x dash y dash to denote the after equation, right? Yeah. But if your equation has it, it's after. If your equation doesn't have it, it's before.
Wait, how did you go from there to there?
From here to
This has to go to this.
here to here?
No, no.
Oh, here to here? Okay, so I've subbed all the things into here. Okay. What do you call it? I subbed everything here into this equation.
Oh.
Because I wanna make it not x and y. I want to make it x dash y dash. Yeah. Okay. That's mapping, right? This is mapping. Okay, all good. Now the next thing, I'm gonna do it by recognition, step by step as well. And for this, I highly recommend you to write it out one by one, to kind of keep track of what's going on. So translating 6 units to the left is making the x turn into x plus 6, or square root x plus 6 as a first step. The next step, reflecting in the y-axis, that's when you turn the x all into negative x's, right? Yeah. Negative x plus 6. And then dilation by a factor of 2 from the x-axis, it's multiplying outside the function. So just in front of everything. Okay, all good? Yeah. This is probably faster, but mapping is definitely a lot better for harder questions. Because recognition relies on you actually recognizing what numbers there are, right? So if you're going from like, I don't know, if you're translating from like a dilation of 3 to like a dilation of 2, you're dilating by what? Like 2 over 3, right? But it's harder to see that because the numbers aren't actually there. Whereas if you're translating from nothing, like just something like this, to something else, you can just put numbers in one by one. Something that's very important when you have something that's affecting the x value on the inside of the graph, like this thing, you see how it's just you're tacking stuff onto the x, right? You're not okay. I want you to think of it like this. I don't want you to add it. Okay, so for instance, for this, I don't want you to think of it as like adding a 6 behind the x. I want you to think of it as whatever x you had originally, get rid of it, and then replace this by that. Because you'll have situations like this. Let's say if I have x is equal to x squared plus 2x minus 1. F of x plus 6, you're kind of replacing these. So this becomes x plus 6 squared plus 2 times x plus 6 minus 1. I feel like it's really obvious when I say it, but this is a reflection in the y-axis, right? Some people would just do it like this because they're like, oh, I just put a negative in front of the x value, right? And then it's like that, and then that. Yeah, but that's wrong because you have to specifically replace whatever x value there is. So wherever there's an x, you put a negative x there, right? So technically, I shouldn't be skipping steps. I should have 2 negative x, like that. In which case, you will tell, oh, right, this one, the negative actually cancels out. So that's just something that I think you should be aware of. That's the difference between the two methods. They both work, obviously, It's just a matter of what your preference is.
But like this. Yeah.
Yeah.
Here's this one.
That's what I did. That's basically what I did in year 12. Yeah. Because I don't think I was exposed to that many hard mapping questions. We're going from hard to hard or hard to easy. Like an easy to hard is when you that's the easiest type of question. You're going from something that has no transformation, like this one, it's a plane, right? To some sort of thing. This is the easiest because all you have to do is add things that are like kind of fed to you onto the equation. So when you're going from hard to hard, that's obvious, right? The other thing is if you're going from hard back to easy, it's not just a matter of looking at what numbers there are. You have to also revert them. So if you see a 2, you actually have to multiply by a half. If you see a +6, you actually have to minus 6. So it's not that easy. But yeah, if you really want to use recognition, it's fine. It always works. It just relies on you having like being able to come up with the correct numbers. Yeah. Let me just quickly take a look at what else is worth going over in terms of transformation. Right. So that's the first half of the notes on transformation, I guess. Again, we talked over a lot of this the other day. This is basically a graph. Give you the transformations. You have to look for the after. Determining transformations, just by the sound of it, it's going to give you before and after, and then you have to look for how to get there, like the rules for the transformation. Okay, so you can obviously do these by recognition. Well, sometimes it's a bit harder, but if you want to do it by recognition, you have to put it into that form that I was talking about, into this form. In which case, every single number actually means something, right? So over here, the problem with this question is that I can't have a coefficient in front of x. I have to take it out. So, and I'll rearrange it as well. So I'd have the -3, which is the multiplier at the front of the question. And then I would have -2 brackets x minus 5/2 all squared minus 1. Just changing the order around. But now you can see, right, that's the A that we had earlier, right? That's the A that we had earlier. The -2. It's not loading. The -2 is the 1/n. That's the H. That's the K. Now everything means something, right? Yeah. That's what they've done here. So recognition, you have to write it in the same form as whatever equation you're using, and then the numbers would actually mean something. Because over here, if you're just looking at this, 5 and 2, they don't mean too much because they're not in the correct form. Like just looking at the 5, that's the incorrect transformation because we're actually translating it to the right by 5/2, right? You don't see that until you factorize the 2 out from the start. Again, if you're doing it like this, the order is dilation, reflection, translation. Yeah, okay. Dilation, reflection, translation. Do you know how to do it by mapping?
No.
Okay. Look, I have gone over this last week. Yeah. It's the part where, okay, so if you have both equations, right, you just compare the part that you can compare. So, oh, and one other thing is, VCAT exams, you have to be very, very careful with what's before and what's after. Just look at this equation, like, look at this question. Do you think gx is before and then the fx is after? No, like, okay, so you have this equation and this equation. What's before, what's after? Image, pre-image. From G. Yeah, okay. Because it says from that graph, right? Okay, so we're fine here because for a lot of the questions, you start off with an easy graph and then you go to a hard one. But that's not always the case. VCAT intentionally sometimes switches around because some people will see this question and be like, oh, easy graph, hard graph. Easy one must be before. And if you have the order wrong, there's no possible way in which like you can get the answer correct, right? So, and that's just something that's, you know, like,
If you count more of them, I mean, that like.
I mean, do it again, like, I guess, because it's very unreliable. Yeah, because you can have transformations at the start that affects the stuff at the bottom, right? So it's not just like a matter of flipping the order. Yeah, just I reckon just to just do it again. Okay, so the way you can compare these two things, I'm gonna say like I'll have this is y equals to x squared, and then this y dash is equal to -1 minus 3 5 minus 2x squared. Okay, so I'm gonna compare everything that has to do with x and everything that has to do with y, and everything that I'm not comparing has to stay the same. Okay, do you still remember us doing that? Okay, so I'm gonna box up this part, and this part is what I'm gonna compare. Over here, if I compare this thing and this thing, you see how there's random stuff on the outside? I can have stuff on the outside, but they have to be the same for both of these equations. But if I had a +2 at the back, I'm allowed to have a +2 here and then compare everything else. But right now, they're not the same, so I can't do that just yet. I'm going to y dash plus 1 up by -3 is equal to 5 minus 2x squared. I'm going to do it like this. Oh, yeah, sorry. It's supposed to be there. In which case, now I'm comparing everything on the left-hand side. And okay, that's fine. Okay, so you can now see the direct comparison between everything that's on the left-hand side, right? And everything that's inside the square, right? There's nothing on the outside that's not the same. Let me emphasize this again. If they both have something that are equivalent, like if I had a 2 here, and I also had a 2 here, then it's okay. I can still compare these, because everything that's beyond them is still the same, right? That's okay, right? Okay, so I'm just saying, whatever you're comparing, you can compare. Okay, so let's just say you boxed up a section to compare, right? For instance, I'm comparing whatever's on the left-hand side and whatever's being squared right now. Yeah. So if I have a 2 here and I have a 2 here, it's not the fact that there's a 2 there that makes me not be able to compare them. I just have to make sure they both have the same thing. That's okay. So everything that I'm not comparing has to be the same. So there's nothing being added at the back.
Yeah.
Same coefficients.
Yeah.
Then I'm good. I can do this despite there being like a number there, right? I'm allowed to do that.
Yes.
So it's the same for this question. Just a quick tip: try to keep the y's on the same side. Like you see how this y is on the left-hand side, and this y is here. Try to compare the y's together, because if you have x's, would also work. That would imply your y value is changing the x value. It's like a different set of transformations that you're not going to learn about. Okay, so it's like if I had like y plus x over 3, and I'm comparing these two, that implies your x value is going to change the y value, which is something you don't learn in methods. So just keep it as like y with y, x's with x's. But it is possible. And okay. And generally speaking, to describe our transformation equation, we will want x dash and y dash to be the subject, right? Because that wise, we can see what's been done to the x and y's. So, easy enough. Here, y dash is equal to -3y minus 1. And you have x minus 5 divided by -2 equals to x dash. For this one, okay, for y, it's very easy to see what's been done to it. 3 things. Negative means it's been reflected in the x-axis. 3 means it's been dilated by a factor of 3 from the x-axis. And -1 meaning that it's been translated down by 1, right? In that order, because of order of operations. it looked something like this, then I would describe the -1 first. I'll move it down first, and then multiply by the -3. So purely order of operations. Here, however, if you want to describe it like this, the order of operations states I have to do the x minus 5 first, right? So I'm translating it to the left by 5, and then I'm dilating it by a factor of a half because it's been divided by 2 from the y-axis, reflecting in the y-axis. So this thing first, and then these two things, because multiplying by 2 and -1 has like the same precedence. Yeah. No, it totally depends on how you write it. So if I write it like this, you have to describe the -5 first because of order of operations. But I could also totally write it like this, right? In which I describe this first. It wouldn't be translating by 5 to the left anymore. It will be translating by 5/2 to the right now. That makes sense, right? Yeah. I think I would prefer you having everything expanded out just because it's more consistent that way. Yeah. Because if you expand it out, you're always dilating first because you're always multiplying first and then adding. If you're doing it like this, so if you're doing it like this, it's not wrong. You can totally do it like this. You will be translating first, which is kind of unorthodox. Just keep it like this. Yeah, that's it.
I think I can. Okay.
Yeah, and let's just match it against what the answers they have. The 3. They explicitly done dilation, reflection, translation. I could say this dilation, this reflection, this translation, this dilation, this reflection, this translation. Because translations here affect the y value. No, okay, you obviously have to follow the order here.
Yeah.
But this thing doesn't affect this thing. So does that make sense?
Yeah.
Yeah, it's like I have to describe this one before this one, before this one. But I can go from this one, this one, this one, this one. I can mix up the order like a bit like that. They don't affect each other. So you might as well have 2 different lines of transformation.
I wanted the one.
Yeah, they just don't affect each other. It's 2 separate equations. They have nothing to do with each other. It's like you multiply this thing by 3. Oh, cool. What's that? No, you are. You totally are. Like I could describe the half first, and then the negative first, and then this. That's got nothing to do with this. Yeah, but it's just that if you do that, it might seem like you're doing it dilation, reflection, translation, and then dilation, reflection, translation. It looks like you're messing up the order when you but generally speaking, you want to do all the dilations, all the reflections, all the translations.
Yeah.
It's the same thing. It's the same thing because your teachers would have like a sample answer, right? And they would probably have it in that order, like that. So it's not to say that you're wrong, but if you have the same sample answers as your teachers, it's easier for them to mark as well. Yeah. Yeah, that's it. That's good. How do I stop recording?